Okay, so along with the idea of actually taking the derivative of the natural log and logs and things like that, we can actually use some properties of logarithms to rewrite these expressions and make them easier to differentiate. So let me show you what I'm talking about. Let me remind you, first of all, of the properties of our logarithms. You probably want to write these down if you don't remember them right off the top of your head, because what we're going to do, in most cases, we're going to expand. So we're going to take something like the log base A of u times v, and we're, instead of having to deal with the product rule in addition to logarithmic differentiation, or taking the derivative of a log, we're going to expand that into two logarithms. Remember, when it's a product, you can add the two logarithms together, and then we have, it's a little bit easier to take the derivative. Okay, same thing, quotient. When a log of a quotient is equal to the difference of the logs. And then sometimes we're going to be able to use our power property as well. And then, of course, these apply to the natural logarithm. So make sure that you are familiar with these rules before we continue to actually use them. All right, so I mentioned this in the last lecture in explaining why log base 7 of x, why its derivative is what it is. We can use change of base to rewrite it as the natural log of x over the natural log of 7, which we pull out that natural log of 7 as a constant in front of that natural log. So I already talked about that, but just as a little refresher. So let's look at differentiating this expression right here. Okay, this would get a little complicated just using the log rule. We could do it. We could absolutely do it with just our log rule. But if we use our properties, it's going to make life a little bit easier. So first of all, I'm going to start with change of base. And I'm going to rewrite the square root as the 1/2 power, because that usually always helps us out, right? Then I'm going to bring out the 1 over the natural log of 4, because that's just a constant multiple. And I'm going to use my power property. The 1/2 power right here, instead of having to do the chain rule inside my logarithm, I can just bring that in front. And ta-da! That's a lot simpler of an expression inside the logarithm than what I originally started with, is it not? And then this right here, we can rewrite, and I'll go ahead and do it here in my first step of the derivative. Since they're fractions, we multiply the 1 times 1, and then the 2 times the natural log of 4. We put the 2 in front, okay? And we'll simplify that here in a second. Not equals, times. Okay, so that's the constant multiple in front. What's the derivative of the natural log? It's the derivative of the inside. Well, in this case, that's 1 over what's on the inside. And then they will probably use the power rule going the other way and rewrite that as 1 over the natural log of 16. And they may go ahead and just put those together right there. Just extend that fraction line and put the x plus 1 down there in the denominator. And that's it, okay? So we took something that looked really, really complicated right here, rewrote it using our properties of logs, and then it was super, super easy to take the derivative of it. Okay, so pause the video, practice with this problem, similar idea, actually a little bit easier because it's just got the natural log, but pause it, work it out, and then come back and see if you did it right. So in this case, the only thing we need to rewrite here is we need to bring down that power in front of the natural log, and then we can take the derivative. 2 is a constant multiple. The derivative of the natural log is the derivative of the inside. Derivative of x minus 3 is 1 over what's in the inside. It's not supposed to be a plus, it's supposed to be a minus. And so then you'll just see it like this, 2 over x minus 3. Okay, so something that would have required the chain rule, in addition to our derivatives of natural logs, very, very easy if we rewrite it using the properties. So those weren't that bad, but look at this thing right here. This is nasty. But if we use our properties of logs, it's really not that nasty, okay? So let's kind of break it down. Overall, we've got a quotient, right? So let's start with that. we've got the natural log of e to the x times x squared plus 1 squared minus the natural log of 2x cubed minus 1, of course, to the 1/2 power. I'm going to go ahead and write my square root as the 1/2 power. Then we've got a product within this natural log, so let's go ahead and split that up into a sum. Okay, and while I'm at it, instead of just rewriting this the way it is, let's go ahead and use our power rule. 1/2 natural log of 2x cubed minus 1. Now, natural log of e to the x. Natural log of e to the x, guess what? That's just x. That is just x, because remember what this is saying. E to some power is e to the x. E to some power is e to the x. So that power's got to be x. So it equals x. And then why do I keep on doing equals? Not what I wanted. Okay, here we go. Plus. Power rule, bring down that 2. Okay, so we've got to do, a little bit of legwork in the very beginning, but it's really not that bad once we get that simplified, because then taking the derivatives of these, it's a breeze. Okay, f prime of x, the derivative of x is 1, plus that 2 is a constant multiple, times the derivative of a natural log is the derivative of the inside. So 2x over what's inside, x squared plus 1, minus 1/2, that's constant multiple. Derivative of the natural log is the derivative of what's on the inside, 6x squared over what's on the inside. And then we just need to try and make this look a little bit better. So we've got 1 plus 2 times 2x is 4x over x squared plus 1. Minus, let's see here, 6 over 2 is 3. So minus 3x squared over 2x cubed minus 1. Notice my problem started out with the square root, and there is not a square root at all in my derivative. Okay. Now, really at this point, I'm definitely looking at my answer choices, because I don't know whether they're going to leave it in this form or if they're really want to get everything over a single denominator. I really doubt they're going to, because the last summer institute I went to, they claimed we're not trying to test their algebra skills. We're trying to test their calculus skills. So simplifying that expression is a test of your algebra skills, okay? So I really don't think that they would make you simplify that further, so I'm not really going to take the time to go through that right now. So pause the video, see if you can differentiate this expression using the same strategies we just used, and then come back for the explanation. All right, so same thing going on. We got a product up here within an overall quotient, so let's split it up. The natural log of x cubed. I'm going to go ahead, hopefully you're okay with me doing this. I'm going to go ahead and split them all up, and I'm going to go ahead and use my power rule, if that's okay. And remember, the square root of x squared minus 9 is not x plus 3. Please don't do that to me. It makes part of my soul die when I see people do that. Power rule here. Nothing else to do in that one. And then I already used the power rule on the last one. So we're good, okay? So we can take the derivative now. G prime of x is 3 times the natural log of x is 3 times 1 over x is its derivative. Plus the derivative of natural log of x minus 3 is just 1 over x minus 3. And then minus a 1/2 times the derivative of the inside here is 2x over over what's inside. Okay, so let's simplify a little bit. We've got 3 over x here. We've just got 1 over x minus 3 here. The 2's are going to cancel here, so then that's minus x over x squared minus 9. Again, I really don't, well, actually, you know what? Let's go through it on this one, because this one's not as bad, because we do kind of need to review this in case they did ask you to do it. If we were trying to get a common denominator right here, first thing I notice is these are not completely 3 distinct denominators. I need to factor this one, because then we've got overlap. okay? So it's really not as bad to get a common denominator. So this one is missing the x plus 3, so I got to multiply top and bottom, and it's missing the x minus 3, top and bottom. All right, this one is missing the x. Hopefully yours isn't quite as cramped as mine is, and it's missing the x plus 3. And then this last one's only missing the x. All right, so here's what we've got. We've got 3 times, I'm going to go ahead and multiply the x plus 3 times the x minus 3, x squared minus 9. Plus, I'm going to go ahead and multiply x times x plus 3, x squared plus 3x. And then we've got minus x squared here on the end. So that's nice because those cancel. Okay, don't lose your denominator. I've seen that happen before. All right, so then let's distribute that 3x squared minus 27 plus 3x. Now, it's kind of looking like we're headed towards something simplifying here, but I don't know. Let's factor a 3 out of the top, x squared plus x minus 9. Yep, not going to happen. Okay, x squared plus x, I'm talking and thinking at the same time. X squared plus x minus 9 is not going to factor. But, you know, we got it to a point where it's nice and neat and pretty there. Okay? All right. Okay, here you go. Try and do this problem. Bit of a challenge, but not impossible. Pause it and come back for the explanation. All right, so we got to rewrite this. Let's start with our properties of logs. So log base 5 of 5x plus, because this is a product right here, log base 5 of negative 4x squared plus 7x minus log base 5 of 2x cubed minus 8 to the 1/3. All right, now there's a reason why I left it as log base 5, because this expression right here, log base 5 of 5 to the x, you guessed it, it's equal to x. Nothing else we need to do here, so let's go ahead and use our change of base. 1 over the natural log of 5, natural log negative 4x squared plus 7x, minus this last one here, the 1/3 is going to come down, so that's going to, whoops, my minus blended in there. That 3 is going to go in front of the natural log of 5. Hopefully you're okay with me skipping that step right there. Okay, change of base, 1 over the natural log of 5, and then when you multiply that by 1/3, okay, that's where that's coming from. Okay, so taking the derivative, okay, we didn't name the function, so I'm just going to go with y prime here. Derivative of x is 1. 1 over the natural log of 5, constant multiple. So derivative of this inside, negative 8x plus 7 over what's in the inside, negative 4x squared plus 7x, minus constant times derivative of what's in the inside, 6x squared over what's in the inside. Whew. So not really anything pretty here. Pretty much just what's going to happen is that these times are going to become single fractions, and then they may rewrite that as the natural log of 125, because 5 cubed is 125. But, well, right here we could reduce all those by a 2. So that becomes 3, that goes away, that becomes 4. But really, that's about it. That's about it. Here, they may factor the negative out of the top and then factor the negative out of the bottom. And then a negative over a negative is a positive. Might do that. But that's pretty much it. There's not much else that can be done to this problem right here. So practice in the textbook.